I'm Adam. I'll be presenting about my student project, which is an augmented reality building identification application, leveraging the CityGML as a data source format. As a quick background, as most would know, a university campus is unintuitive and difficult to navigate, and we want something better than using 2D maps. So the objective was to have a solution in that the augmented reality application that will overlay the building with its 3D model, and we further provide contextual information such as the building names or events for extra assistance. We are trying to use the CityGML data source because of its widespread use. The idea behind it is that if we can parse CityGML, the application can be easily adapted to any city or campus. There are some main challenges to consider. The main issue is that to develop AR applications, it normally uses a 3D development engine or game engines, which don't normally support the CityGML format. They normally only accept the standard 3D formats like OBJ or STL, and they don't retain semantic data. The other issue is in outdoor applications. Traditionally, AR applications would use markers for accurate content placement, but this isn't suitable outdoors. So we need to rely on GPS, which has limited accuracy. For the current development pipeline, we are handling the CityGML data in 2 steps. The first step being that we extract the geometric details and convert it into a suitable 3D format. And separately, we are passing the semantic data into an embedded database, and with these 2 split formats, we are then packaging it into the application for further use. In terms of the application development itself, we are using Unity's AR Foundation and Google's ARCore. AR Foundation gives us a quick pipeline to develop Android and iOS applications, and ARCore framework is chosen because it comes with geospatial features, which allows us to have location-based content. So the 3D building models that we created in the previous steps are anchored using its global coordinates in the application. And to improve accuracy, ARCore has a visual positioning system, which improves localization by matching camera images with Google Street View images. And for the results, it shows a lot of potential, especially for distant buildings. Users can have a better spatial understanding of the campus as it provides the direction of buildings, even without line of sight. The lack of line of sight actually means that accuracy doesn't matter as much as we know the general direction of the buildings that we need to head towards. For closer buildings, accuracy is generally good when we're under VPS coverage, but as you can see in the video towards the end, moving out of a covered zone causes a reduction in accuracy, which results in bad alignment. There are still some limitations with the current process, mainly that the CityGML data parsing is not very efficient and computationally expensive. This makes the development process less efficient as more manual handling is required, and this makes the application also static, in which that if we want to add more buildings to it, we have to recompile each time, which takes about 30 minutes every time. And also memory usage becomes a problem as we add more buildings into the application, especially if we go with a higher level of detail. And lastly, accuracy is also very reliant on VPS coverage, which is limited. For future works, we're going to improve the parsing. It will be better to actually parse it to a remote database or cloud database and have the application fetch the data at runtime. And this should allow us to add more buildings or cities into the application at any time we want to and expand it towards any region. Thanks.